Yes, good morning. Welcome to this session on Autodesk Inventor. I'm going to demonstrate to you a preview on how to program a CAD model designed in Autodesk Inventor. Then we use our Inventor Ultimate CAM 2026. This purposely Ultimate CAM is just integrated design and manufacturing software which is blended or embedded in Autodesk Inventor for the purpose of ensuring that we do precise machining through G and M code generation. So it's a digital format precisely designed for automating programming, where we change from manual part programming to automated computer part programming. So in this session I will demonstrate the key parameters on how to do programming using Autodesk Inventor, Inventor CAM 2026. So mainly this, as I said, it's built as integrated part in Autodesk Inventor Professional, originally designed or developed by HSM Works. It can also work for Fusion, for SolidWorks. We call it Inventor CAM, and also it is embedded to work as Fusion HSM. Basically, from Autodesk Inventor, the purpose is just to transit or to help transit from CAD to CAM as a way of automating manufacturing. So, welcome to this presentation. We're going to do turning. This software can do what we call 2.5D milling, that is drilling, pocketing, contour, facing operations. You can also do what you call 3D milling, adaptive clearing, parallel, scallop, and also rest machining. It also allows you to do what you call 4 and 5 multi-axis, and or what you call the multi-axis machining. So in our session today, we will look at how can we do turning for roughing, facing. In case we have threading, we also do threading. Then we do a real-time simulation to see how the tool will be changing or moving from one point to another as it moves material visually. And then we also do generate the G-code so that we are able to see these G-codes. I like using this software for programming because it has the updated version for generating the post-process for all machines available. Yes, it combines what we call CAD and CAM in one interface, and also able to support what we call 2.5D to 5 axis adaptive technology. It also automates in efficiency, it improves efficiency, it saves time and speed, and it's also suitable for education and industrial manufacturing. This is what I normally use in my industry for purpose of producing. So let's go to the CAM. This is the part we are going to do. Let's check the parameters before we start programming this. We are using aluminum 2014 alloy, so let's check some of the parameters before we proceed. I'm just going to check the maximum diameter here, as maximum diameter is 29. I'll also check maximum length from this point, maybe maximum length from this point to this point, from this point here. You see, he can't give you that point. Why? Let me show you the best way you can do this. Check the length of this so that we're able to know how much we're going to give for the stock. So up to here I have 64.76, which is close to 65. So let's start in our programming. Let's start our programming. Can we check this diameter here? This is 14. So let's check start our programming. Let's go to CAM. Once you have done installation of the Autodesk Inventor, you also download the setup, but ensure that you have a licensed version. Don't use the crack version. Then go to setup here. We are going to start now our process here. Go to setup. In our setup, we want to define the machine here that we are going to use turning Okay, then here change that we're going to use milling, turning, mill turn, then the spindle. So we are going to offset this, flip this axis like this. You can put this so that you're able to see it well. You can also flip x-axis like this, flip x-axis like that. Yes, so this is where the point is from this side. You can change this, or we can pick an origin. For example, you have this, so we have what we call the Z and ZX plane. So this is ZX plane. Or you can also check the model orientation. For example, if you pick the model orientation, it will not give you well because it is taking as a meaning. But here we need to take as a length, which is the ZX plane, and then offset from the stock front. Let me put this. I want to show you something here. Offset from the stock front, stock front. For example, if I put 0, what will happen with this? So the difference here, I want to put sector 5 from the stock front. It has a sector 5. Then come to relative. So change relative, and then outside I want to use 5. So I have the diameter of that is diameter of 40. So if it is 40, what is 5.2? It should be 6. Okay, yeah. So this is close to 40. This is 5.9, 5.7. So this is the diameter I have for my stock, and then facing 2 millimeter, and then the holding I can say it is 30. Holding 30. And then come here, and my program number I can put it as 20, that is 20, 30. Now that's the program number. Then here I can say I'm using cement. Let me use 828. Set number 1. Then click OK. So we have done our setup. From this setup, now we go to operations. So if you look at this setup, this is what we have. The transparent one is our stock. So here we need to do, first of all, because I've done 2 millimeter excess, so I need to do facing. From facing, I can now do this is rough turning. From rough turning, I can also do groove turning. So to do it, let's look at the groove turning. How can we do groove turning from this side? Okay, but let's start facing first. Facing operation. So here, come to this tool, pick the tool, click on the tool, then click on new turn tool, because we are now doing turning. Change here the insert. I like using not DNMG, because I like using the DNMG machines. Don't worry. So here the size is 11. This is 3. This is 4 by 3. Then this is G. Holder is 20 by 20. My holder is 20 by 20. The angle is J. Clamping point is multiple D. So these are the clamping for the holder. Where the clamping here, then clamps here. So this is called multiple. So you can use single, that is screw, pin, multiple lock, rigid lock, or clamp lock. I like using multiple lock. Okay. Then the type of the tool I'm using is right tool, not left tool. Then the angle, relief angle is -3. So that is what the tool I have. Then the orientation, you can change orientation here. If you pick this, it changes. So I'm using this upper tool. Feed here, it is 600 for roughing. 600. Then maximum diameter is 41 for the stock. Then here you can change the feed rate per. So you can change it depending on the material, but because of aluminium, I'll leave it by default. Okay. Then select the tool. From here, come to this, because it has this. You can put, like, say for example, you put -1, it goes inside. So because I'm using the model front, or like I say the stock front, for example, stock front, Then if it is stock front, I can put -2 so that it can go now inside, because I want to remove the excess material from the stock. So put it stock front, then come here, leave this by default, go to this, say multiple passes. I want to for you to see the multiple passes, but I can use 1 millimeter to cut. I'm doing rough cutting, so I can say 0.8 for example, for you to see what we'll be doing. Then at the same time, the same tool will do facing to finish facing, and then this okay, full traction, then we click OK. So it has done facing. Then next we come to rough turning. From rough turning, I'm using the same tool for rough turning, and I don't want to change the tool, so go here, then check from the front. I'm using stock. Let me use stock front, and then here I use the model back, where I can extend this by maybe 1 millimeter, for example, 1 millimeter. Then go to this offset, because it's the external turning, so I'm using OD, which is stock OD. And then here you change. I'm using I want to use Kane cycle. Kane cycle is a code which is used to reduce repetitive or to simplify programming. Then here I will do what we call axial and radial, so it can do turning at the same time along X, at the same time turning along Z. So that's what I call axial and radial turning. I want to leave a material of 0.1, 0.1 for the tool that will come to do finishing. Then I click OK. You will see it gives you or regenerates the tool parts. These are the tool parts. And then there's this material remaining here. I want to introduce another program called groove turning. So this, I want to do groove turning. I want to pick a tool, and I put a new tool here for groove turning. Come to general, tool number 2. Here I want to put it as square. It has a 0.2 radius. Parameter it is 3. It's okay. Holder, I'm using multiple. External grooving, 20 by 20. The feed here it is 400. Feed 400. Okay. Then select the tool. From this tool, now come to this. I want to assume, for example, if I don't want to cut all of it, I can just say from the model front, I can put either, let's say, a selection, pick selection. I don't want to waste time this side. I can pick this one as my selection. Then model back, I can say also selection. I don't want it go further away. I can want to pick this region, that region. Yes. I can say maybe -1, for example. -1 in case, but let me put 0. Then we come here, let it be by default finishing. Same tool to do finishing, so sleeve. So let me put it smoothen. Then here click OK. Let's see, it has calculated. You see now this region, and then come to finishing operation. From this finishing operation, change the tool now. I can pick the same first tool, but I want to create a new tool for finishing. So pick a new tool for finishing. I want to use VNMG here. Then say 16. From 16 it is 04, 04, 04, 04, which is 04, 02. Thickness. This is 02. Is it 02? This is 04. 04. G multiple, holder, feed is 1500 for finishing. Then click OK. Select the tool. Then come here, change to -1. Then here change this to both of them. In case of any material that was left, the tool will remove it. Then from there we click OK. This one is calculated. So let's do simulation. But before you do simulation, let's go to part off. In case we need to have our final part, click on the part off. That is parting off. The tool already by default has picked the tool. So as to change these parameters here, where do you want to part off? By default it's okay. Come here. You allow this feed, for example. I want to put it 5. Then there's no finishing. let it be by default, and then okay. Then let's now do a simulation for this program. Let's do a simulation. We'll see what will happen. So click here, simulate. You can change orientation to see how the tool will be coming in. Move a little bit up. Then allow the stroke to be visible. Click on this stroke to be visible. Then from there, this is just a simulation. Click on here, then run. As facing, this rough turning. This rough turning. You will see at every corner, every section here, the first tool, this is second tool, then this third tool. Each one has its own operation. And now you can see this is our final output. This is our final product. This is our final product. As you can see, after we have done our turning and parting off. The different colors shows the different operations. That's why they are showing different colors. You can also show controls of transparency. In case of the tool, you can show points or axis. So this is what we have done. And then next phase is, now can we generate G-code? So click here, post the G-code. Take here the machine as Siemens. Come here, take turning, then take the controller. You have this controller Siemens 840C mill turning. So this Siemens turning operates with Siemens 808, Siemens 828. So click on Siemens turning, and then click here post. It will open up the program. So click just save, then after you click save, it now gives you the G code. So this is the language that we use in the industry. It's called G and M code. This is the one now you take and then you transfer or send to your machine. This is what we call G code, which can operate in Siemens 808, 828, and even 840, depending on how you have set your parameters. If your limit speed, for example, here is not like so 6,000, you have to change the maximum limit speed. So this is the maximum limit speed for the spindle, and then this is homing. Other machines normally use G28 or G75, like Siemens use G53 and also G75 for homing. But if you use G28, you can now use right here. For example, you can write G28, G91, G0, then X0. Also, you put semicolon because I don't want this one to run on my machine. G91, G0, Z0. So you can home using these codes. So these are what we call the G and M code. So we have done programming